Welcome to Ascending Grades. Today we are going to present Teso in the head of the preparation of Kcse 2025. We are doing our final touches. So, welcome. Invite a friend. Ensure you do subscribe, like, drop a comment, and share. Here comes the paper. And we are going to start with the front page. That is how it is. So now we can proceed. So now we can proceed to section A. Where first question reads, the micrometer screw gauge in the figure below gives the reading of the diameter of a piece of wire. Given that the length of the wire whose diameter was read using this micrometer screw gauge here is 4 centimeters. Then you are asked, determine the volume of the wire. So you are told that the length was 4 centimeters. Now, this one is supposed to be giving us the diameter. So now, how will we get the diameter? So we are going to make a reading from this micrometer screw gauge. So you can see from the main scale, we have 1, this is 2, this becomes 3. We have the down half scale here, 0.5, 1.5, 2.5, 3.5. So it becomes 3.5 plus the thimble scale reading is supposed to be, this is 25, so 26, 27, 28 times 0.01 becomes 0.28. So that our diameter becomes 3.78 millimeters. So now this one is giving us diameter in millimeters. We are having a length in centimeters. So our diameter is 3.7. Yes. with these parts, the diameter was 3.78 millimeters. Then our length is 4, and this one is supposed to be 40 millimeters. Therefore, we want to get the volume. So volume of this one will be given by pi r squared, then times the length. Then this becomes 3.142. We get the radius by getting a half of 3.78. Then we square it, then we multiply by 40. So this becomes, from the calculation, it will be 448.94 cubic millimeters. In case you want to give it in cubic centimeters, you can say or 0.449 cubic centimeters. In case in our body in circular motion, moving at constant speed, is said to be accelerating. Explain this. It keeps on accelerating due to instantaneous change, due to instantaneous change in velocity. And where do we get this one? This is from the change in direction. In direction. Then question 3 reads, explain reason why dropping dust particles in a still room does not trace a straight vertical path. Remember, these are particles that are in air. Then they will keep moving in a zigzag path. That is the path that they are likely to trace. And now we are being asked that we explain. So we know that air particles are in continuous random motion. Therefore, if we have to explain, we can say it is continuously hit by invisible or the unseen air molecules which are in continuous random motion. That is the response that we are supposed to give in that. Can move to question 4. State one factor for that bimetallic strip relies on its working. Remember, it is made of different that is metals of different linear expansivity. So that becomes the factor. The difference in linear expansivity. That becomes the factor. 4b, two objects made of the same material and having the same mass are heated allow me share the links to several people. Are heated to a temperature of 35 degrees Celsius, above that of the atmosphere, then allowed to cool in still air for 30 minutes. State one factor that will determine their final temperature. They are two objects made of the same material, having the same mass, and they are at the same temperature of 35 degrees Celsius. Then they are let to cool within 30 minutes. So the shaping of these objects could be the factor. So this one, we can say the surface area to volume ratio. Now, why do we say so? Because the surface area to volume ratio, it gives the surface, shows the surface exposed to air, then it means that it is going to cool very fast. Question 5. In the figure, a tube contains two immiscible liquids, P and Q. If the density of Q is 900 grams per cubic meters, that of P is 1,200 kilograms per cubic meters, calculate the height H of the liquid Q. So this one, let me first show that this one, we are given that the density here is 900 kilograms per cubic meters, and this one is 1,200 kilograms per cubic meters. Then if you look at this one, both ends are open, so it means that a common atmospheric pressure will be acting. A common atmospheric pressure will be acting. Then pressure on the left arm will be the same as the pressure on the right arm. Therefore, we can say pressure due to Q will be the same as pressure due to P. And therefore, height of Q, density of Q times our G will be the same as the height of P times the density of P, G. So there is something that we are supposed to look at here. You can see we are given a 3 centimeter difference here. So What will be the height column of P? It will be minus 3 centimeters. So from here, let me use a different shade. From this part up to this one, we are expected to have 9 minus 3, which is supposed to be 6 centimeters, like that. So, height of Q, we don't know, times density of Q is 900, times 10 will be the same as height of P. We have seen it is 6 centimeters. It is equivalent to 0.06 meters times 1,200 times 10. So we are looking for our height Q. H of Q will be 0.06 times 1,200 times 10 divided by 900 times 10. And this one is supposed to be giving us 0.08 meters, or you can say H of Q will be the same as 8 centimeters. So if you want to give it in centimeters, then it will be it will be 8 centimeters. In terms of the molecular forces, explain the difference between liquid and gaseous states. So in liquids, the forces are weak and molecules are free to move. Can I move to our question 7? Which reads, in a faulty mercury, in a faulty mercury, in a glass thermometer was found that mercury level stands at 3 centimeters mark in the tube at 0 degrees Celsius and 18 centimeters when in steam above boiling water at normal atmospheric pressure. Calculate the temperature when the mercury stands at 12 centimeter mark. This one, you'll draw a column showing at steam point, we expect to have 100 degrees Celsius. Then we have at 100 degrees Celsius, we do expect 18 centimeters. At 0 degrees Celsius, we are having a height column of 3 centimeters. Then in between, we want to know the number of degrees at X when we have it having a column of 12 centimeters. So in this case, you just equate and say that's 18 minus 12 over 100 minus x, this one, is equals to 18 minus 3 over 100 minus 0. So how does this one look like? This becomes 6 out of 100 minus x is equals to 15 out of 100. So we want to have a part where we can remain with x as the subject of the formula. So if we cross multiply, then it becomes 600 is equals to 15 times 100, which becomes 1500. Minus 15x. So we want to have 15x to be the subject of the formula. So we can either bring it to this left hand side, then we shift this one to the right hand side, or we bring the 1500 to the left hand side and we retain negative 15x. So we'll say that either way will be correct. So if I use the negative way, I take this one to this part, then it will be 600 minus 1500 is equals to negative 15x. So negative 900 becomes negative 15x. Then my x becomes 900 out of 15. Remember, all of them are having negatives. So my x becomes 60 degrees Celsius. 60 degrees Celsius. So we have question 8. Sketch on the axis a graph of mass per unit volume. This means density of water against temperature from 0 degrees Celsius to 10 degrees Celsius. We know normally water has what we call the anomalous behavior, especially at the 4 degrees Celsius. Therefore, we expect to have the maximum density of 1 gram per cubic centimeters at 4 degrees Celsius. So you can see we are having our temperature here. So suppose I say this is 4 degrees Celsius, then I'm expected to draw it like this. So I'll point out that this becomes the maximum density of water at 4 degrees Celsius. That is of 1 gram per cubic centimeters. The other one for volume, if we have volume against temperature, then we expect it to have the minimum volume at 4 degrees Celsius, like this. And therefore, you, especially this one, for density, you must show that the maximum density is 1 gram per cubic centimeters. Cohesive forces, while in water, in water, it spreads due to higher adhesive force than cohesive force. Like that. So the comparative terms must be used where unnecessary. Figure shows the velocity time graph for the journey of a car in 100 minutes. Then you're told describe the motion between B and C. Between B and C. So these parts. So you can see the velocity is constant, and this means that the body or there is no acceleration. So you can say the car moves at a constant velocity, or you can say no acceleration. But this is the best part. Explain how the racing cars have been designed so that they can negotiate sharp corners. Remember these cars, the chases are almost hitting the ground. So this design makes that the COG is at the low point. So they have lower center of gravity and a wider base. And a wider base. Making it more stable. Remember, physics has turned out to be of more theory. The questions of writing are not calculative questions. Say the effect of reducing the diameter of a spring on its spring constant. So it's like you're supposed to derive from the factors affecting the spring constant of a spring. Therefore, when it comes to the diameter of the spring, if you reduce it, then you're going to produce a stronger spring constant. So the smaller the diameter, the larger or the stronger the spring constant. Like that. Water due to increase in density. Salt water, more upthrust, force than fresh water. We can have our section B. I'm trying to be rushing because of we're having some power issues. State the Newton's second law of motion in terms of momentum. Then it says that the rate of change of momentum is directly to the resultant force that takes place in the direction of force.